So as we know, we studied according to the class 9th. As I told you, the chapter name is motion, or we can say motion in one dimension. Generally, we will call it as motion, or we can say motion in what, guys? Motion in how many dimensions? One dimension. Okay. So now if you go to the class 11, you will get motion in a plane, motion in like circular motion, motion in 2 dimensions, motion in 3 dimensions. Like that, many chapters will come under this. So this all we used to call, everything we used to notice it. Whatever this is describing about the motion, like we can say, there is a separate branch of physics which will deals about this, all these things. That is what we used to call as kinematics. Understand? So to study the motion of particles, like you can take, maybe it is one dimensional motion, or maybe 2-dimensional motion, or maybe it's a rotational types of any type of motion. If you are studying about the motion of the particles, then, and you have to remember, without taking into account of forces and as well as energies involved in it. So not discussing about the forces exerting and the energies are involving, just if you are studying the motion of the particle, then that is what we used to call as, what is to call, guys? We used to call as what I told you, kinematics. Understand? So when I say motion or motion in a one dimension, everything we used to call as kinematics. Now, so you should not discuss about any forces. That is why have you noticed that entire chapter, do we find anywhere force like anything, like energy or force or anything? Anybody? I'm asking you people. Do we discuss that? Do we solve anything regarding force or energy or anything? Everyone? No. Am I right or wrong? Only we are discussing about the motion, how the body is moving. That's all. So that is the branch of physics actually, but it's a branch of mechanics actually, which will deals about the motion of the particle. That is only called as kinematics. Write it. Kinematics is the branch of mechanics. Kinematics is the branch of mechanics dealing with the study of the motion of the particles, dealing with the study of the motion of the particles, dealing with the study of the what, guys? Only discuss about the motion of particles, but it won't discuss about what? Without taking
your force.
Without taking into account, the forces, without taking into account the forces and energies involved. Energies involved.
Sir, can you please say it again?
Yeah. Branch of mechanics dealing with the study of motion of particles without taking into account the forces and energies involved. Now, my question to you all, how many of you remember the beginning of this chapter, like with respect to surroundings? Always you can see changes with respect to surroundings. We can describe either the given particle or the given object is said to be in motion or said to be in rest with respect to frame of reference. Do you all remember that, all of you? When we can say object is in same position,
Origin.
object is in state of rest or object is in state of motion. Ellame remembered or not? Everyone? Yes. So if the particle is said to be in rest, when we can say particle is said to be in rest, I want to know. All of you? When you relate it to the surroundings, if it does not change with their position, then we will say, even with respect to time also, then we will say the object is said to be in what? State of rest or state of motion? Everyone? Does not changes its position. So it is said to be rest if its position related to the surroundings is not changing. So that the body is said to be rest or said to be in motion. Everybody? Said to be in?
Rest.
Rest.
If the particle is said to be in motion, when you people will say particle is said to be in motion? Anybody? Yes? Lingesh? Yes.
Position.
So if the body, if its position relative to the surroundings and also changes with respect to time, then we can say the body is said to be in motion. Am I right, all of you? Please respond, guys. Yes. So we have been made many examples to describe when the object is said to be in motion and when the object is said to be in state of rest. Yes or no? Clear, all of you? One response. Understanding now? Now. So let us discuss. Of course, I no need to make again. So based upon the position where we are seeing, that is only we used to call some point. Anybody can tell me? Beginning chapter I taught. Reference point. Understanding? So with respect to the reference point, either the same body appears to be in state of motion or the same body appears to be in state of, everybody, state of
Rest.
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 So now, let us see that we studied the motion and all. So let us discuss what are the types of motions. This is only Mr. Kishore have a big doubt. Translational motion. Am I right, Mr. Kishore? Translatory motion or translational motion or whatever it is. Okay. So shall we discuss now, everybody? All of you. So today's class will study motion and types of motions. That's all. So we can see that in our daily life, we'll come across various types of motion. If you notice in our surroundings, many types of motions, we can notice it. So like, what is the main, you can notice it. If you are coming out, immediately you can see that the air is blowing. We will feel it. If the air will come and touch us, we'll feel it. That is what, like the motion of the wind. And we people, day and night is forming. That is due to the motion of what? Day and night is forming due to the motion of what? Everybody.
Yes.
Due to the motion of
Yes.
earth. Understanding? Due to the motion of earth, we are getting the day and night. That is what, like motion of the planets, motion of the wind. Even we are people are moving here and there. So everything we used to call as motion only. So motion can be classified mainly into 4 types. All of you right. First one is random motion. What is the first one? Everybody? Random motion. Second one we used to call as translational motion. Translational motion. And third one we used to call as rotational motion. What is the third one? Everybody? Rotational motion. And last one is called as oscillatory or vibratory motion. Oscillatory or vibratory motion. Okay, actually, you know that, guys, this is actually class 8th concepts, but class 9th again we are making. So what is the general types of motions we people knows? One is random motion, second one is what? Translational motion, third one is what? Everybody? Rotational motion, and fourth one is oscillatory or
Vibratory
motion.
Okay, now first type of motion. What is the first type of motion, everybody? Yes? Random motion. So very simple. Random motion, if you go back to the chemistry chapter 1, while we are studying the properties of liquids, that is what integrated. While we are studying the properties of liquids, can anybody tell me, is the particles of water remains constant or always they are moving here and there within a liquid? Everybody, Agalya? Is the particles of liquid, is it in a constant place or they are moving here and there continuously within a liquid? Everybody?
Moves here and
Moving
there.
within a
Moves
liquid.
here and there within a liquid. So to prove that, I have suggested one activity. Any one of you, can you remember that activity? Let me know that. Any one of you. One activity we have done that. To collect the, you take talcum powder and you put one, you take one beaker of water And if you put one kind of any kind of like talcum powder, or we can take like that powder of the flowers or something, you can see the
Sir, or we can take seeds, no, sir.
yes,
Zigzag motion.
yeah. What is that motion you have written, Mari?
Brownian motion.
Ah,
Brownian motion or zigzag motion.
yes. Do you remember all of you? Brownian motion or zigzag motion. Clear, everyone? Please respond. That is only we'll see.
Random movement of particles in anywhere.
Yes. To prove this, we have done that many things. Yes or no? All of you? Clear? That motion is only we used to say. This kind of motion only we used to call as what? All of you? We used to call as random motion. Purima, understand, Ara? Just I am saying. Clear, guys? Now, if you take, for example, in our surroundings also you can take wind or air. You can see that the particles in which direction they will move, we don't know. Understanding? So particles are very light in weight, so they can travel in any direction. Suppose if you on the gas cylinder, you can see the gas which is coming out from the cylinder, it is also a gas particle. So you cannot predict that it only will goes in a particular direction. They can randomly goes in any direction. Like this, we used to call as, what is to call? Random motion. Do you all understand? There is no definite path. If there is no definite path, they will move along. There is no definite path. That is called as random motion. So please write it. In this type of motion, the particles move randomly. In this type of motion, random motion, keep heading random motion. Random motion. In this type of motion, comma, the particles move randomly. Particles moves, particles moves randomly. Understand, everybody? So what do you mean by randomly? They will travel. That means, they do not move along a definite path. They do not move along a definite path. Clear, Mr. Nivedan? Okay. See, I will introduce new kinds of motion, so many things in this chapter. Even I am going to introduce a motion of random projectile motion also I am going to introduce here. Okay, everybody? So keep it in mind that. So random motion means what? Particles moves randomly. They do not move along a definite path. What is the example, guys? What is the example we can make? The motion of dust particles in wind or in air. That is what you can write it. Example. The motion of dust particles. Dust particles in wind or air. Okay, everybody. So that is only the first one. So what is the second type of motion, everyone? Translational motion. What is that? Translational motion. Okay.
Sir, it's like a wave.
No, listen first. I'll say. Okay, translational motion. Basically, again, two types of translatory motions we have. So translational motion is separate, or translatory motion. Whatever is convenient, you can write it. Translational or translatory motion. So translational motion, observe very carefully. What do you mean by translational motion? Means every particle of the body has the same displacement. That is what we used to call as translational motion. Suppose, for example, I will take, all of you understand. So let me consider somebody of your friend is cycling. Okay. So now if you notice it, this is the B part of the bicycle and this is the A part of the bicycle. Now, I will say a body has traveled 1 kilometer. 1 kilometer means here again A will come and here B will come. And this is the position of the cycle after 5 minutes or 10 minutes, whatever it is. Now you tell me, I'll say the distance between the initial point of A front tire and final point of front tire is 1 kilometer. Means in the sense of, what about the distance between the back tire and back tire also? Everybody? Yes, please.
1
What is the
kilometer.
distance between the back tire
1
and back tire?
kilometer.
That is also how much it will be? Everybody?
1 kilometer.
1 kilometer only. Understanding? So for example, I'll say
Mute start video participants chat share. Mute.
Yeah, please listen. So if you take, who is that fellow? So if you take, suppose my car, I'll say my front part of the car is traveled 1 kilometer. Okay. So it means in the sense of my back part of the car also will travel how many kilometers? Everybody? Yes,
Space.
please. My back part also will travel how many kilometers, guys? Same 1 kilometer. Yes or
Same
no?
1 kilometer.
Yeah, because as the car is traveling, suppose I will say my car front part traveling 5 kilometer, back part traveling 2 kilometer. Is it possible, guys? Is it possible to make one part of the
No,
body?
sir.
That is what. For example, let me consider, forget about this all. Yourself you take. Now you are walking 1 kilometer. Now I will say my legs are walking 2 kilometer distance and my head is walking 1 kilometer. Is it possible to say?
No, sir.
Yes, please respond, everybody. So
No,
what is
sir.
happening? Each particle of the body is traveling the same displacement or variable displacement. Everybody, each
Same
particle
displacement.
Same displacement.
That is what we used to call as translational motion. Do you all understand, everybody? All of you? Please respond.
sir.
Yeah, that is
Yes,
what.
sir.
So now write it.
Sir,
Every
can you
part-
please say any example
I
for
will
this
say, Mari.
opposite
I will
to
say
the...
these all examples only, Mari.
No, sir, opposite to translation.
Huh?
Opposite to translatory motion, sir.
Opposite to translatory motion, there is no opposite. It is a one kind of motion. It is. That's all. There is no body will shows different displacements. Understand, Mari?
Okay, sir.
So, for example, I will say you that is also. If you take, for example, rocket, you can take it. Rocket launching theriyuma allame. Yes. You can see at different levels, different parts of the rocket will be removed. Is it right or wrong? Then in this case, it is not the translatory motion. Each part of the rocket is not traveling the same distance. Clear? After certain height, the wings will be removed. After certain height, body is removed. Finally, in the orbit, only who will reach? In the orbit, only who will reach? Satellite matada. Okay. So only satellite will reach. So in this case, the rocket is not a translatory motion because each part of the rocket is not traveling the same distance. Clear? Displacement. Clear? Understand, Amari? That is what. So
Yes,
translatory motion means translational motion means. Again, are you there in meeting? Write it. In this type of motion, comma, every particle of the body has the different displacement or same displacement. Everybody, every particle of the body having the, yes, please. Kishore,
Same
same
displacement.
displacement. That is what we used to call as translational motion. Okay, girls, Shivani, Alvin, that is the meaning of translatory motion. You can make many examples also. Okay, now, like you can take, like for example, if you consider the train. So now the train is parked in a particular station. So we all knows that, for example, it is having a 3-bogie train or whatever it is, you can consider. So now if you notice it, So for example, the engine is traveled, I'll say from here to, the engine is traveled 1 kilometer distance. Means the first bogie is also traveled how many kilometer distance? Everybody, same 1 kilometer. And the second one is also traveled how many kilometers? Everybody. Yes, please. 1 kilometer.
1
Understand?
kilometer.
So every part of the body will has the same displacement. Then that body is said to be in what motion? Translational motion. Clear? Understand? Now, this translatory motion will be in two types. Like the translational motion can be, the motion can be along a straight line. This motion, which motion? Translational motion. Translational motion can be along a straight line, or along a curved path. Along a what, guys? Along a curved path. Clear, everybody? So if it is along a straight line, that is what I said. Translational motion is two types. One is rectilinear motion, or we can say linear motion, and second one is curvilinear motion. So translational motion is how many types, guys? Translational motion, how many types? Everybody. First one
Two
is
types.
what? Rectilinear, or we can say simply linear motion. And second one is what? Respond, Ra. Curvilinear motion. Okay, Shivani, they are on meeting, no response. Curvilinear motion. Okay, so one is rectilinear, another one is what, guys?
Audio now.
Curvilinear motion. So now you can see curvilinear motion. Spelling you can write C-U-R-V-I L-I-N-E-R, curvilinear motion. Okay, so that is what. So what is rectilinear motion? By this time you understand. Traveling in a what line? Everybody.
Straight line.
Straight line.
That is what. So you can take like the train is speeding along a straight track. So that is like it. That is what we will say one-dimensional motion. As we all studied, a body is moving in a car, is moving in a straight line and all. So this is only we'll consider as a how many dimensions? Everybody, one dimensional. Understanding? One-dimensional motion. One-dimensional motion. That is what you have to remember. So example, what is the example you can take? All of you, train is accelerating. Train speeding along a straight track. Train speeding along a straight track. Clear, Mr. Darshan, Sanjay, Lingesh? Straight track.
Yes, sir.
That is what we used to call as rectilinear motion. So it is also referred to as what? How many dimensions? How many dimensional motion it is? All of you?
One
Single
dimension.
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 That is
One
what.
dimension.
Okay. Do it. Next, curvilinear motion. The path of if you take like batsman for a sixer, for example, we all people are like cricket, you all people knows. So now this is the batsman. So now batsman will hit the ball. The ball will goes, and it will come and will fall here. Am I right or wrong, everybody? All of you? Yes or no? Please respond.
sir.
So this kind of thing we used to call it as curvilinear motion. Or let me take now, Mr. Kishore is standing on the terrace. Okay, so this is his roof, and here he is standing on the terrace. Now he dropped the ball. He thrown the ball. The ball will goes and will travel and will come like this. Am I right or wrong? The curved path it will take. Clear, everybody? Nobody will respond. Yes, please.
Yes, sir.
Yeah.
Yes,
So
sir.
like this kind of motion we used to call as curvilinear motion. Curved path. For example, you are having a car and the curved road is appears. This is what the road. Okay, national highway. So imagine that you are traveling in a national highway now. So your car comes in a curved road. So that you are in a curved motion, or you will go in a straight line. Yes, please. You'll go in a straight line or curved road also. You'll travel in a curved path.
Third path also.
Third path.
Then your body is said to be in a curvilinear motion. So when the body is traveling in a curved path, that is what we used to call as curvilinear motion. And remember this curvilinear motion, it is referred to as 2 or 3 dimensional motion. How many dimensions? 2 or 3 dimensional motion. Okay. So keep it in mind, only for class 9th, only one. Now what we are studying, how many dimensions? 1 dimensional, 2 dimensional? Yes, please.
One
One
dimension.
dimensional motion. Okay. But in this, definitely in these classes, coming classes, definitely I will introduce the 2-dimensional motion also. Okay, guys, everybody, are you interested? So that is what. So this is what translational motion. Understand, Mr. Sanjay now, Mr. Kishore, Purima, what is translatory motion? Any doubt?
Yes, sir.
Yeah. Next, third type
Yes.
of motion. What is the third type of motion? Everybody, what is the third type of motion?
Rotational motion.
Rotational motion. Now, go to your home and you, of course, you're all sitting in a home only. Now, if you're having a fan, look into the fan now, everybody, and tell me. Look into the fan and tell me, is the fan is rotating like free or it is rotating about a fixed axis, fixed point?
At
Yes,
a fixed
Fixed
point.
point.
it is rotating about a fixed point. Now, you all know bicycle. How many of you are having a bicycle? Bicycle, you can see the entire wheel is rotating based upon the middle point. Am I right or wrong? With the help of axle. That is what we used to call as axle. Yes or no? All of you? Yes.
Yes, sir.
If you are having
Yes.
a car, you can see both wheels are attached with the axle. Am I right or wrong? Everyone? Yes, please.
Yes, sir.
Yes. So like
Yes,
this, you
sir.
can notice it. This is what we used to call as rotational motion. And if you visit the Gandhi Park or the new park which is open near to the bus stand, yes, not every vehicle, you can see, you'll be finding the merry-go-round. Have you noticed that merry-go-round? Like one boy will, anybody will stand here, okay, so that it will be rotating around the particular path. Yes or no? Merry-go-round theriyuma? Ellame, yeah, giant wheel, very good English. Giant wheel. If you go to the giant wheel, you can see that. So everywhere we people are hanging within the boxes. So we people are particular path we are going, and middle it is traveling, particular axis. So like this.
Centripetal force.
Yeah, like that thing only, Mari. Clear? So rotational motion, right. If the particles of the body revolve in a circle, if the particles of the body revolve in a circle, if the particles of the body revolve in a circle, if the particles of the body revolve in a circle about the same axis, that is very, very important. About the, all of you, same axis means a fixed point. That is what? Gandhiji photo, you see that? Gandhiji 150 birthday and all. In his hand, he is having something. That is what, like making that wool, that, sorry, dress. I remember that chakra we used to say that. Social studies also will get it. Am I right?
Yes,
Chakra he used to rotate. Gandhi Tata
Yes,
will
sir.
sit and will rotate. That is what it is. Clear? Yeah. That is what. Khadi. Very good English. Khadi it is. Yeah. Swadeshi cloth. So about that same axis, if it is revolving, that is what. Yeah. Yes, Sanjay. Hand spun cloth. That is also about a fixed point. It is revolving. That is what. Now, you might be watching movies and all. Have you noticed it? Olden days, for removing the shell of a dal and all, they use 2 big stones. Even our Tamil Nadu and Andhra cultures, you can notice it. Rendu big stone irka. They will one stone is placed above the another stone, and middle they will put some small opening. Here they will put the grindings, that what are the cereals and all, and they'll keep on rotating. We'll be having one stick like thing. By holding that, they'll be keep on rotating, so that all this cereals will break the shell and they'll come out. Am I right or wrong? Have you noticed it? Movies and all. Purimara? Yes? Don't know. My home still we have. When I'm childhood, my mother is used to do this one. Now it's not. But you find it in movies and all, you can see that. Even you ask your grandparents, they'll say, olden days. Nowadays, we have a mission to remove the cell. Olden days, they will use these stones only. So the stones also, they will revolve around the particular axis. So keep on rotating. they will functioning also. Clear everyone? Please respond.
Sir, even generator also, sir.
Yes. Yes.
Inverter, the generator.
So that is what it is. So fixed axis. So if any kind of thing rotating in a circular path about the same axis or fixed axis, then the motion is said to be what, guys? Then the motion is said to be what?
Rotational motion.
Rotational motion.
To take daily life, wall clock. Wall clock you can see 3 pins, minute hand, second hand and hours hand. All these 3 things is revolving continuously about a particular path. Am I right or wrong? All of you? Yes, that is what. So clock. So that is also is to say about rotational motion only. So write the definition. All of you. If the particles of the body revolve in a circle about the same axis. If the particles of the body revolves in a circle about the same axis, about the what? Same axis, comma, then the motion is said to be rotational. Then the motion is said to be what? Then the motion is said to be what, guys?
Rotational.
Rotational motion.
Yes. Motion is said to be rotational. Motion is said to be rotational. Examples. Yes, Abhirami. Ceiling fan. Kishore is saying earth revolving around the sun, everything. Yeah, you can make it. Rotation of earth on its axis, not around the sun, on its axis. Okay, guys? Not around the sun, on its axis. Own axis it will rotate. Am I right or wrong?
Yes, sir.
Yes. Clear, everybody? So rotation of earth on its axis. Second one, fully used in drawing water. You all notice temples and all, if you go now also, they will draw the water from the well. Am I right? Have you noticed it? Nobody will answer. Okay, enjoy.
Yes, sir.
Yeah. So you can see that there one ring-like structure will be there. Have you noticed it, Nivedan? Ring-like structure will be there with the help of thread. They will
Yes,
put
sir. Over that, there will be a rope.
that is what we used to call as a pulley. Okay, so pulley, that is also rotational motion only. Pulleys we can say. Pulley used in drawing water. Pulley, P-U-L-L-E-Y. Pulley used in drawing water. Drawing water. Next, windmill, very good. Abhiram is saying windmill. You can find many examples. You can take it a merry-go-round. Merry-go-round is very thing. Motion of a fan. Merry-go-round. Merry-go-round, if you go to the Gandhi Park also, you can find it. Merry-go-round. Okay. Motion of a fan. Everything we are saying that examples of rotational motion. Is it okay, all of you? Clear? Yes. Please respond. Next one.
Yes, sir.
Oscillatory or vibratory motion. Yeah, Laksha. Globe. Globe is also the same thing. Next one. Oscillatory or vibratory motion. Oscillatory or vibratory motion. Now, write the definition. A to and fro motion about a fixed point is called oscillatory or vibratory motion. A to and fro motion. To and fro means going back and coming forward, going back and coming forward, going back and coming forward. That is what. A to and fro. A to and fro motion about a fixed point is called a to and fro motion about a fixed point. About a fixed point. About a fixed point is called oscillatory or vibratory motion. Is called oscillatory or vibratory motion. Understand, everybody? Respond, Ra.
Yes, sir.
Yeah. Oscillatory or what is to say? Oscillatory or vibratory
Vibrate motion.
Hmm. Okay, that is what examples. So can you anybody tell me to and from motion in your daily life? You might be having somebody of in your home also you are having.
Sir, pendulum.
Pendulum
Yeah.
clock.
Pendulum clock. Very good. Very good, Lingesh. Lingesh also texted. Very good. So pendulum clock. So if you notice that pendulum clock is a merger thing, you can see every 1 hour, tang tang, clack 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 clack, 1 o'clock, like that it will says. Yes or no? So pendulum
Oh,
clock. Take the pendulum clock. So about a fixed point, you can see. Please mute. About a rigid point. Kishore, Enara. About a fixed point, that is what we can say rigid surface, or we can say a fixed point. Understanding? The bodies keep on rotating. It will oscillate and it will goes like this also. Like this, it will be keep on moving. Am I right or wrong, everybody? Yes, please. All of you. So pendulum clock will be like this only. Is it right or wrong, everybody?
Yes, sir.
Yeah. So that is what you have to remember. Pendulum clock. Example. The motion of the pendulum of a clock. 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 Is it okay, everybody? Clear? Any other example? Yeah, swing, yo-yo. Okay, very good, Lingesh. Next, when the string of the guitar is plucked, when the string of a